Now we'll move on to the next topic, that is network prefix. Network prefix defines how many bits in an IP address belong to the network portion, like a street name versus the host portion, like a house number. For example, 192.168.1.0 by 24, whereas by 24 means the first 24 bit identify the network. It helps routers group and route traffic efficiently. IPv4 address encodes two values. Number one, the network prefix. IPv4 address encodes two values. Network number, that is network ID. It's like a neighborhood, and host ID is like a specific house. Network prefix distinguishes portions. The prefix, for example, by 24 splits the address. This actually splits the address. Okay. Bit set to 1 is equal to the network ID, first 24 bit, and bit set to 0 is equal to the host ID, last 8 bits. This is the network ID, this is the host ID. Okay. For example, binary mask, slash notation, and subnet mask. You can see here, when bit set to 1, that is the network ID, as I said, and the bit set to 0 is the host ID. Okay, let's move on. Public and private address. What is public addressing? Public addresses are routable across the internet. That means public IP addresses are unique, globally routable addresses that is assigned by the ISPs, that is the internet service providers, to identify devices onto the network. For example, a website server. For example, 203.0.113.1. Whereas the private addresses are restricted to the network, local network. Private IP addresses are mainly reserved for local network, for example, home and the office, and aren't routable on the internet. For example, 192.168.1.1. They save public IP space and improve the security. Public addresses are like global phone numbers, unique and reachable worldwide, like websites. Private addresses are like internal extensions, only work within local networks, for example, home and the Wi-Fi. Address class and default subnet mask. Address class ABC defines subnet mask, for example, class A, that is 255.0.0.0. Internet access for a public host. Internet access for a privately addressed host. Network address translation, that is NAT. NAT translates private IPs to public IP, like a mailroom forwarding letters. Proxy service. It acts like as a middleman, hiding the private IPs while you are browsing. Now, we will come to the new topic, which is IPv4 host address configuration. This diagram shows a manual IPv4 network setup for a devices. IP address, the device assigned to 192.168.0.2, like a unique house number on the network. Subnet mask, that is 255.255.255.0, which defines the local network size here of 254 devices. Gateway, that is 192.168.0.1. It is the router address that connects the local network to the internet. Preferred DNS, primarily 192.168.0.1. Router may handle the DNS. For backup, that is alternate DNS 8.8.8.8, which is Google's public DNS for internet access if the router fails. Now, the IPv4 address and subnet mask. First IP is in range in network addresses. Last IP is the broadcast address, as I said. Host can be assigned address in between, and default gateway, which is the router address that connects a local network. Domain name system, that is DNS server addresses. It is the Google public DNS for internet access if the router fails. Static versus dynamic host address configuration. Static addressing. It is manually assigned fixed IP addresses, good for servers but too hard to manage in large network. DHCP, it is the Dynamic Host Configuration Protocol. It automatically assigns IP address to devices, making network setup easy and scalable. Automatic Private IP Addressing APIPA. APIPA, when DHCP fails, devices self-assign IPs in the 169.254.x.y range allow local communication but no internet. Here, 169.254.x.y, it means your device couldn't get a proper address from the DHCP, which is the Dynamic Host Configuration Protocol. Now, IPv6 addressing. IPv6 address format, it uses 8 groups of 4 hex digit. For example, 2001, 0DB 8, 8583, etc. Hex digit and canonical notation. It is a shortened IPv6 by removing leading zeros and replacing consecutive zeros with ... hash. Network prefix. First 64-bit that identify the network like a neighborhood. 64-bit host identifier. It is the last 64-bit uniquely identifies a device like a house number. Network prefix mask first 64-bit. It is the /64 subnet means the first half is the network portion. Global and link local interface addresses. Linked local addressing FE80. It is for the local network only, like private chats. Static is manually set, like a saved contact. SLAAC is auto-configures the address using routers like DHCP for IPv6. Dual stack host operate both IPv6 and IPv4 at the same time. That means IPv6 and IPv4 run simultaneously. Please note that IPv6 longer but not smarter with auto setup. So you need a manual intervention in this. Now, we'll learn about to compare the protocols and ports. First is the transport layer. It manages end-to-end communication between the apps, like a postal service for data. Identify each application protocol. It also identifies each application protocol. It uses port number to direct the traffic to the right application. For example, HTTP, the port number is 80. It tracks the sessions. It keeps conversation between the devices organized like a call logs for data. Protocol ports. It are the virtual doors for application to send and receive the data. Server port. It is a fixed door where services listen, for example, web services on port 80. Client port. It is a random temporary door for your device request, for example, your laptop's browser.